The strangest thing about Earth's history is not how much we have discovered. It is how much of the story was never preserved at all. Whole landscapes vanish before they could leave a trace. Countless living things were born, moved, suffered, adapted, and disappeared without ever becoming fossils. Even the rocks beneath our feet are not a perfect book, but a damaged archive, with pages torn out by time, heat, pressure, water, and silence. We often imagine the past as something waiting to be found, but perhaps most of it is not hidden. Perhaps it is simply gone. So when we look back across billions of years, what part of Earth's story are we actually seeing, and what part has disappeared forever? When we try to imagine the history of Earth, it is easy to picture something orderly, almost like a great book resting beneath the ground, with each layer of stone acting like a page, each fossil like a sentence, and each discovery like a word that was waiting patiently for human eyes. It is a comforting image, because it suggests that the past is still there, complete and silent, and that all we need to do is dig carefully enough to read it. But the real Earth is not that kind of book. It has never kept its own history in a clean, protected library. It has buried things, crushed them, heated them, washed them away, folded them into mountains, dragged them beneath oceans, and broken them apart grain by grain. The ground beneath us does remember, but it remembers unevenly. It remembers certain coastlines, certain shells, certain bones, certain chemical traces, certain moments when mud covered something quickly enough to protect it. And then, around those rare memories, there is a much larger silence. This is where the question of what is missing from Earth's story begins. Not with a dramatic secret, not with a hidden chamber waiting to be opened, but with the quiet fact that most things that once existed were never preserved at all. A forest could grow for thousands of years and leave almost nothing recognizable behind. A shoreline could move back and forth across a continent and later be erased by erosion. A small animal could live, reproduce, and vanish without leaving a fossil that any future creature would ever find. Even a whole environment could disappear so thoroughly that only a thin change in the color or chemistry of rock hints that it was ever there. The past was not automatically saved. It had to pass through very narrow conditions to become evidence. It had to be buried at the right time, in the right place, with the right materials around it, and then survive millions or even billions of years of pressure, movement, water, heat, and chance. That means the story we read today is not the full story of Earth, but the surviving part of it. This does not make science weaker. In a way, it makes it more honest. Scientists do not hold a perfect transcript of the planet's life. They hold fragments, layers of sediment, mineral grains, fossil bones, shells, pollen, footprints, isotopes, ancient soils, and traces so small they can be recognized only by careful measurement. From those fragments they build careful explanations, always aware that the archive is incomplete. And this incompleteness matters, because it changes the way we think about the past. We are not looking at a finished mural with a few dusty corners. We are looking at a damaged wall where some colors remain bright, some have faded, and whole sections were lost before anyone knew they should be protected. Earth's story is not missing because someone took it away. It is missing because the planet itself is active, restless, and old. It does not simply record time, it transforms it. It turns living bodies into dust, sea floors into mountains, mountains into sand, and sand into stone. Then, sometimes by accident, it leaves behind a clue. So the first thing to understand is this. When we look backward into deep time, we are not seeing everything that happened. We are seeing what survived the journey into the present. One reason the gaps in Earth's story can feel so surprising is that the evidence we do have often looks so solid. A fossil bone in a museum case seems final. A cliff face with clear horizontal bands looks like a stack of pages. A diagram of geological time can make the planet's past appear orderly, divided into named chapters, coloured sections, and neat boundaries. From a distance, it can seem as if everything has its place. The Cambrian sits before the Ordovician, the Jurassic comes before the Cretaceous, the age of dinosaurs gives way to the age of mammals. But these clean names and lines are human tools. They help us organize a past that was never actually clean while it was happening. Earth did not live through its own history in labeled chapters. It passed through storms, seas, deserts, reefs, forests, ice, heat, impacts, eruptions, quiet ages, violent ages, and long ordinary stretches that left almost no trace. The names we use are like shelves built inside a damaged archive. They do not mean that the archive itself is complete. This is why the question, what is missing from Earth's story, cannot be answered only by pointing to the gaps between the things we know. The missing parts are not just empty spaces in a textbook. They are the countless ordinary realities that never had the right conditions to become part of the record. Imagine a shallow sea filled with soft-bodied creatures, drifting, feeding, hiding, and dying in quiet water. If the mud buried them quickly, if oxygen was low, if scavengers did not tear them apart, if the sediments hardened and survived, some trace might remain. But change just one condition, and the same living world could vanish from the future almost completely. Its animals could decay. Its soft tissues could be eaten. Its seafloor could be stirred by currents. Its sediments could later be eroded or transformed. Nothing magical would have happened. Nothing secret would have been hidden. The world would simply have failed to become evidence. This is a very cold truth, but it is also a useful one. The past does not owe us a record. It does not preserve itself for our questions. When scientists find fossils, rock layers, mineral signals, or ancient chemical traces, they are not opening a perfect diary written by the planet. They are studying leftovers from a long process of survival and destruction. Even the most famous discoveries are surrounded by things that were not saved. Around every skeleton, there were many bodies that disappeared. Around every preserved footprint, there were countless steps erased by wind, rain, or the next tide. Around every ancient forest recorded in coal, there were other forests that rotted, burned, sank, or were recycled without becoming a clear page in stone. This matters because it teaches us to read Earth's history with humility. A gap does not always mean that nothing happened there. It may mean that too much happened in the wrong way for the evidence to last. It may mean the land was exposed and eroding instead of receiving sediment. It may mean rocks were formed but later destroyed. It may mean the organisms were small, soft, rare, or living in places where preservation was unlikely. So the first axis of this story is not about a single missing event. It is about a different way of seeing the whole past. Earth's history is not a complete road with a few broken stones. It is more like a long path crossing mist, water, fire, and pressure, where only certain footprints hardened before the rest were washed away. To understand Earth's story honestly, we have to become comfortable with a strange kind of incompleteness. We can stand in front of a fossil, or touch a stone wall, or look at a map of ancient continents, and feel as if the past has come close enough to hold. In some ways it has. A shell pressed into limestone, a leaf shape preserved in shale, a band of ash from an old eruption, a ripple mark hardened from an ancient shore. These are real pieces of time. They are not guesses. They are not fantasy. They are the surviving edges of worlds that once had weather. Seasons, water, hunger, movement, birth, decay, and change. But they are edges, not the whole world. The danger is not that we know nothing. The danger is that the fragments can look so convincing that we forget they are fragments. A single fossil can make an extinct animal feel suddenly complete, but that animal lived inside a larger environment that may be only partly known. A layer of rock can tell us that a sea once covered a place, but it may not tell us every life form that moved through that water, every storm that stirred the bottom, or every long quiet year when nothing was buried in a way that would last. The record is real, but it is narrow. It is truthful, but not total. This is why the question of what is missing from Earth's story must stay close to the ground. It should not become a doorway to careless claims or imagined histories. The missing parts are not an invitation to invent whatever we want. They are a reminder to treat every surviving clue with patience. When scientists study deep time, they do not simply fill empty spaces with imagination. They compare rocks from different places, They look for layers that match in age or chemistry. They measure minerals. They study fossils in context, not as isolated treasures. They ask whether a gap is caused by erosion, by non-deposition, by heat, by pressure, by later damage, or simply by the low chance that anything there would have been preserved. The silence itself becomes something to study, but carefully. A missing page can tell us something about the book only if we first admit that the page is missing. That honesty is what gives the story its strength. Earth's history is not less meaningful because it is incomplete. In some ways, it becomes more meaningful because every clear trace has crossed an almost impossible distance to reach us. A footprint had to be made in the right mud and covered before it vanished. A bone had to escape complete decay. A layer of sediment had to harden, remain buried, and later be exposed without being destroyed. Even then, someone had to notice it, study it, and place it among other evidence. What we call the past is therefore not only what happened, it is what happened, survived, reappeared, and could be understood. That is a smaller thing than the whole story, but it is also a precious thing. It means that the earth beneath us is not a complete library, and not an empty silence either. It is a damaged archive with enough remaining traces to teach us, and enough missing spaces to keep us humble. Before we ask which chapters are missing, we first have to accept that the book was never complete in the way we wanted it to be. Most of Earth's missing story was not lost after it was written down. It was never written down in the first place. That is the quiet difference we have to hold in mind. When we picture the past disappearing, we may imagine a finished record being damaged, as if a library burned after all the books had already been placed on the shelves. But for most of Earth's history, there was no shelf, no page, no protected place where ordinary life could be kept. A body died and was eaten, scattered, dried, dissolved, or returned to the soil. A leaf fell and became food for fungi and insects. A track crossed wet sand and was erased by the next wave. A riverbank collapsed, not into preservation, but into movement. The world was always active, and most of that activity led away from evidence, not toward it. This is one of the first reasons the answer to what is missing from Earth's story must begin with ordinary conditions rather than extraordinary mysteries. For a living thing to become part of the fossil record, something unusual often had to happen. It had to be buried quickly enough to avoid complete destruction. It helped if it had hard parts, like bone, shell, teeth, wood, or mineralized structures. It helped if it lived near mud, ash, lake sediment, river deposits, seafloors, or other places where burial could happen before decay erased the form. It helped if later heat and pressure did not destroy the remains. It helped if the rock survived long enough to be lifted, exposed, and found. These are many narrow gates. Most lives did not pass through them. A jelly-like animal in open water might have lived in great numbers and still left almost no trace. A small insect in a dry upland forest might vanish entirely, unless trapped in rare conditions. A plant community on land might return to the earth so completely that only pollen, spores, charcoal, or chemical hints remain, if even those survive. A herd could cross a plain every season for generations, but unless a few bones or footprints entered the right kind of sediment, the future would never know the rhythm of that movement. In this way, Earth's story is not only shaped by what happened, it is shaped by what could survive the natural hunger of time. Decay is not a failure of the record. It is the normal condition of life. Bodies are meant, in a biological sense, to return their materials to the world around them. Bacteria, fungi, scavengers, sunlight, oxygen, water, and weather all work against preservation. They break down the soft parts first, then weaken the hard parts, then scatter what remains. Even when bones are left behind, they are not safe. They can be cracked by pressure, dissolved by groundwater, rolled by rivers, exposed to air, or buried in places that will later be eroded. Every fossil, then, is not simply a dead thing. It is a survivor of many chances. And around every survivor there is an invisible crowd of lives that were just as real, but not as fortunate in the language of evidence. This is why missing history is not empty history. It may be full of organisms, seasons, migrations, storms, growth, sickness, reproduction, and quiet change. But fullness in life does not guarantee fullness in stone. The earth does not preserve what matters most to us. It preserves what conditions allowed. So when we ask what is missing from Earth's story, one answer is almost painfully simple. Most of the ordinary living world is missing, not because it was unimportant, but because ordinary life usually disappears. It is not only bodies that disappear from Earth's story. Whole places can pass through time and leave behind only a faint, broken outline. A coastline can exist for thousands of years, receiving tides, storms, shells, seaweed, fish, drifting wood, and the slow footsteps of animals moving along wet sand. And later that coastline may be lifted, cut apart, drowned, or worn away until almost nothing remains in the form we would recognize. A river can bend across a plain for ages, carrying silt, feeding wetlands, shaping banks where plants grow and animals drink, and then shift its course, leaving older channels to dry, fill, or vanish beneath younger deposits. A forest can stand where there is now desert. A shallow sea can cover land that is now high plateau. A lake can gather bones, pollen, and ash for a while, then drain, shrink, or be buried under new sediments. These were not empty backgrounds behind the lives of ancient organisms. They were worlds, and many worlds do not enter the record cleanly. This matters directly to the question of what is missing from Earth's story, because life cannot be separated from the places that held it. If the place disappears, much of the meaning of the life disappears with it. A fossil tooth may tell us that an animal existed, but the full rhythm of its world may be much harder to recover. What did the air feel like in that valley? How often did rain fall there? Did rivers flood gently each season, or did they tear through the land after long droughts? Were there insects in the undergrowth, algae in the water, birds or flying reptiles overhead, roots holding the banks together, animals hiding in shade that never became stone? Some of these questions can be approached through careful evidence. Sediments, isotopes, pollen grains, ancient soils, preserved plant remains, trace fossils, and the arrangement of rock layers. But even with those tools, the recovered landscape is usually partial. It is more like hearing one low note from a song than hearing the entire song. The physical earth keeps changing the stage after each scene. Wind grinds rock into dust, rain moves soil downhill, glaciers scrape land clean, rivers cut through older deposits, waves chew away cliffs, volcanoes bury surfaces under ash or lava. Tectonic movement lifts seafloors into mountains and pulls other rocks downward, where heat and pressure alter them beyond easy recognition. None of this is strange for a planet like ours. It is the normal work of a living geological system, but it means the story is being edited at the same time it is being written. There is no still moment when Earth stops and stores everything for later readers. The archive is always exposed to the same forces that made it. This is why some missing parts are not dramatic holes, but gentle erasures. A small wetland may have held a rich community for centuries, but if its sediments were later oxidized, disturbed, or washed away, the future may receive only a thin stain or nothing at all. A grassland may have supported countless animals, yet open, dry environments often preserve less than muddy lakes or river floodplains. Mountain slopes may have carried forests and streams, but steep land tends to shed evidence as quickly as it creates it. Even places that seem important to us now may have been poor record keepers then. Earth does not preserve every environment equally. It favors certain accidents, quiet basins, rapid burial, low oxygen, mineral-rich water, sediments that harden and survive. Because of this, the landscapes we know from deep time are not simply the most important landscapes. They are the ones that happen to pass through the narrow doorway into evidence. Around them are many lost settings, vanished shores, erased floodplains, ancient soils with no clear surface left, islands swallowed by subduction, valleys cut away before their sediments could settle into stone. To ask what is missing from Earth's story is therefore to ask not only which creatures are gone, but which homes are gone with them. The missing past includes weather that left no calendar, rivers with no remaining banks, forests with no trunks, and coastlines whose waves ended long before any mind could remember them. By the time we reach the end of this first layer of the question, one thing becomes clear. The surviving record of Earth is not fair. It does not preserve the past evenly, and it does not choose what to keep according to what was most alive, most beautiful, most complex, or most meaningful. It preserves what had the right body, in the right place, under the right conditions, and then survived the long damage of time. This creates a quiet bias in the story we inherit. Hard shells have a better chance than soft skin. Teeth have a better chance than muscle. Muddy seafloors often remember more than dry hillsides. Low-oxygen lake bottoms may protect what open air would destroy. A creature that lived near sediment could enter the record more easily than a creature that lived in forests, mountains, or acidic soils where remains dissolve and scatter. Because of this, the Earth we reconstruct from evidence is real, but it is not a complete mirror of the Earth that was. It is a mirror with missing glass, reflecting some places sharply and leaving others dim or absent. This matters when we ask what is missing from Earth's story, because the missing parts are not random in a simple way. They follow patterns. Entire kinds of life are harder to see. Soft-bodied organisms are less likely to be preserved unless conditions are exceptional. Small creatures may be overlooked or destroyed before fossilization. Environments where erosion dominates may leave fewer long-lasting records than places where sediment quietly accumulates. Tropical forests, upland habitats, fragile shorelines, and many ancient soils may have held rich life, yet still leave only scattered hints. Even when fossils are found, they often represent only certain moments, certain disasters, certain burials, certain lucky interruptions in the normal process of decay. It is almost like listening to a very old conversation through a wall, hearing only the words spoken loudly enough, near enough, and at the right angle to pass through. The conversation was fuller than what we hear. The world was fuller than what the stones can repeat. Scientists know this, and that knowledge shapes how they read the record. They do not assume that the absence of a fossil always means the absence of life. They ask whether the rock from that time and place was capable of preserving life at all. They ask whether the right kind of rock still exists. They ask whether it has been exposed, searched, dated, and compared with other evidence. They ask whether the missing signal reflects true absence, poor preservation, or simply the limits of what has been found. This careful distinction is one of the most important lessons in the study of deep time. A gap is not automatically a mystery in the sensational sense. It may be a warning label placed by nature itself. Here, the conditions for memory were poor. Here, the evidence thinned. Here, the page was never written, or was written in material too fragile to last. And yet, those gaps still matter. They remind us that the story of Earth has always been larger than the archive. For every preserved reef, there may have been other reefs reduced to fragments. For every coal bed that records an ancient swamp, there were wetlands that left no such clear layer. For every dinosaur skeleton mounted in a hall, there were countless animals that lived and died in places where their bones never entered stone. For every ancient footprint hardened in mud, there were endless steps taken across surfaces that dried, cracked, flooded, or blew away. What remains is not false. It is precious precisely because it is limited. The surviving record gives us real knowledge, but it also teaches restraint. It asks us to notice the difference between what the evidence shows, what it suggests, and what it cannot tell us. This is where the missing story becomes more than absence. It becomes part of the method. The silence around the evidence tells us to slow down, to avoid pretending that every blank space has already been solved, and to respect the narrow path by which any trace reaches the present. Earth's story is missing so much not because the past was empty, but because preservation is rare, uneven, and deeply dependent on chance. The ordinary world was always there, breathing, growing, eroding, dying, and beginning again. Most of it simply passed through time without becoming a readable mark. The fossil record is one of the most powerful ways Earth speaks to us, but it does not speak in a continuous voice. It speaks in preserved bones, shells, teeth, leaves, pollen, tracks, burrows, eggs, impressions, and sometimes the faint chemistry of bodies that are no longer there. It gives us astonishing windows into worlds that ended long before any human existed. Through fossils, we can know that trilobites once moved across ancient seafloors, that forests once grew from plants unlike the trees around us today, that dinosaurs walked, nested, fed, and died across landscapes that are now stone, and that mammals change slowly through long spans of time. These are real records, and they are not small achievements. Yet the more carefully we listen to the fossil record, the more clearly we notice its pauses. Between one fossil and another, between one species and the next, between one environment and a later one, there are stretches where the voice becomes faint or silent. This silence does not mean the Earth was empty. It means that life was passing through conditions that did not always preserve it, or that the preserving rocks have not survived, or that we have not found them yet. This is why the silence between fossils belongs directly to the question of what is missing from Earth's story. Fossils are not evenly scattered through all places and all times. They gather where the conditions allowed them to gather. Marine animals with hard shells often entered the record more readily than soft-bodied creatures drifting in open water. Bones and teeth often survive better than skin, organs, colour, sound, behaviour, and daily movement. A dinosaur skeleton may tell us that a body once lay in sediment, but it cannot fully restore the smell of the air, the calls of insects, the texture of the plants, or every quiet motion of that animal's life. A fossil leaf may carry the shape of a plant into the present, but not every season that touched it. A footprint may preserve one moment of contact between foot and mud, while thousands of other steps vanished before the surface could harden. The fossil record is therefore not a film of life. It is more like a set of still images, some sharp, some blurred, some missing altogether, arranged across an immense room of time. To read those still images honestly, we must remember that they show both presence and limitation. They show that something was there, but they do not show everything that was there. They can reveal patterns of change, extinction, adaptation, and movement, but they do so through evidence that survived by chance, by chemistry, by burial, and by later discovery. Around every fossil species we name, there may have been related forms that left few or no remains. Around every transition we can study, there may have been many smaller steps hidden by poor preservation. Around every famous fossil bed, there are vast regions and long intervals where the record is thinner. This does not make the fossil record unreliable. It makes it selective. It is truthful in what it preserves, but it is not complete in what it can remember. And once we understand that, the missing parts of Earth's story no longer feel like empty blanks. They feel like the quiet spaces between surviving notes, where life continued, changed, disappeared, and began again without always leaving a readable mark. The fossil record favours certain bodies, and this is one of the quietest reasons Earth's story can look different from the world that actually lived. A shell has a better chance of surviving than a soft body. A tooth has a better chance than a tongue. Bone has a better chance than skin, blood, colour, warmth, sound, or fear. This does not mean that hard-bodied creatures were always more important, more numerous, or more central to life's history. It only means that they had materials more likely to enter stone. Calcium-rich shells, mineralized skeletons, teeth, scales, and woody tissues can resist destruction longer than soft organs and delicate tissues. They can be buried, mineralized, replaced, or impressed into sediment in ways that fragile bodies usually cannot. Because of this, when we look backward through fossils, we are not seeing life with perfect fairness. We are seeing life through the filter of what could endure. This filter matters deeply to the question of what is missing from Earth's story, because many forms of life may have been common, active, and ecologically important, yet still poor candidates for preservation. Soft-bodied animals, worms, jelly-like organisms, early delicate creatures, small insects, tiny larvae, thin leaves, fungi, algae, and countless microscopic communities could pass through the world with very little chance of becoming visible to us. Some did leave traces under special conditions, and those rare deposits are precious because they show how much ordinary fossil beds may leave out. But those exceptional windows also remind us how unusual preservation can be. Most living bodies are built for life, not for geological memory. They are made to move, feed, grow, reproduce, heal, and decay. After death, the same softness that once allowed them to live often made them disappear quickly. Scavengers could tear them apart. Bacteria could consume them. Oxygen could break down their tissues. Water could dissolve or scatter what remained. Sunlight could dry and damage them. Currents could carry them away before mud had time to cover them. A creature might have lived a full life, played a role in its ecosystem, left offspring, shaped the lives of other organisms, and still vanish so completely that the rocks would never speak its name. Even where fossils do survive, they often preserve the durable outline of a life, not the whole living presence. A skeleton may remain, but not the pattern of breath. A shell may remain, but not the soft animal that once occupied it. A footprint may remain, but not the reason the animal moved in that direction. A burrow may remain, but not the full behavior of the body that made it. This is why the silence between fossils is not only a silence between species, it is a silence around the softer parts of existence. Much of life's texture is missing. Colours that faded, calls that left no mark, migrations without tracks, nests that collapsed, bodies eaten before burial, communities too small to notice without the right conditions. Scientists can sometimes infer parts of these lost realities from anatomy, sediments, trace fossils, chemical signals, and comparisons with living organisms. But inference is not the same as complete recovery. It must stay close to evidence. The missing softness of the past cannot be filled honestly with imagination alone. It has to be approached carefully, through clues that remain. So when the fossil record seems to show a world dominated by bones, shells, teeth, and hard outlines, we have to remember that this is partly the bias of preservation. Earth's ancient life was not made only of hard things. It was also made of tissues, movements, small bodies, fragile forms, and quiet relationships that the record could rarely hold. What is missing from Earth's story is not only a list of unknown species, it is the living fullness around the species we do know, and the many delicate lives that time allowed to pass without a durable trace. The gaps between fossils can make the past feel uncertain, but they do not make it meaningless. In fact, they are one of the reasons the study of ancient life has to be so careful. If fossils formed everywhere, from every body, in every environment, then reading Earth's history might seem simple. But because they formed unevenly, because they survived unevenly, and because they are found unevenly, scientists have to treat each fossil not as a complete answer, but as one piece of a much larger pattern. A bone is studied with the rock around it. A shell is understood through the sediment that held it. A footprint is read with the surface it crossed. A fossil bed is compared with other beds, other ages, other regions, and other forms of evidence. The goal is not to pretend that the missing spaces are filled. The goal is to understand what the surviving evidence can honestly support and where it must remain quiet. This is why the question of what is missing from Earth's story is not only a question about absence, it is also a question about method. A gap in the fossil record may mean that organisms were rare, or that they lived somewhere else, or that the right rocks have not yet been found. It may mean that the bodies were too soft, the environment too exposed, the sediments too disturbed, or the later history of the rocks too destructive. It may even mean that a real biological change happened quickly in geological terms, leaving fewer intermediate remains than we might hope to see. Each possibility has to be tested against evidence, not chosen because it sounds most dramatic. That careful restraint is one of the quiet strengths of science. It does not turn every silence into a story. It asks what kind of silence it is. Is it the silence of no life, or the silence of poor preservation? Is it the silence of rocks that were never deposited, or rocks that were later eroded? Is it the silence of an undiscovered place, or of evidence too small to notice before better tools existed. These distinctions matter because Earth's missing story cannot be treated as a single empty space. It is made of many different kinds of loss. Some losses happened before burial, some happened after burial. Some happened because rocks were changed by heat and pressure. Some happened because ancient surfaces were exposed to wind and water until they were gone. Some are only temporary, waiting for a new discovery to narrow the darkness. Others may be permanent, because the material that once held the evidence no longer exists in any readable form. The fossil record, then, teaches a slow kind of honesty. It tells us that ancient life was real, even when it was not preserved, and that preserved life must be read within its limits. It shows us that knowledge can grow without becoming careless. A newly found fossil can sharpen a lineage, extend the known range of a group, reveal a body plan that was once unexpected, or show that an environment was richer than previously thought. But even then, the new fossil does not restore the entire lost world. It gives one more window, one more surviving note, one more edge of a page. Around it there is still silence, and that silence should not frustrate us too quickly. It is part of the shape of deep time. The ancient Earth was not waiting to be perfectly remembered. It was living, changing, burying some things and erasing others. The fossil record lets us hear part of that long life, but it also reminds us that the full voice of the planet was always larger than what stone could keep. If fossils are the voices of ancient life, then rocks are the rooms those voices had to survive inside. But the rooms themselves are not safe. A fossil may never reach us because the body was lost. But even when something was buried, even when sediment covered it, even when a layer began to form around it, the story was still not protected forever. The rock that held the evidence had to survive its own long and difficult journey. This is where another kind of missing history begins. We often imagine layers of rock as stable, stacked neatly under our feet, with the oldest below and the youngest above, waiting in order. In some places, that picture is useful. A cliff face can show one bed above another, and the sequence can tell a real story about water, mud, sand, ash, reefs, deserts, lakes, or ancient seas. But across the whole planet, the rocky archive is far more damaged than that simple picture suggests. Layers can be broken, tilted, folded, melted, buried too deeply, scraped away, or cut by younger forces. Some rocks were never deposited at all in certain places. Some were deposited, then later removed. Some were changed so strongly by heat and pressure that their earlier details became difficult or impossible to read. Some were pulled down into the earth by plate tectonics, where their older story was partly recycled into the planet itself. So, when we ask what is missing from Earth's story, we cannot only ask which fossils failed to form. We also have to ask which pages of stone were lost after they had begun to exist. Imagine a shallow seafloor where fine mud settles year after year, slowly covering shells, burrows, grains, and chemical traces of the water above. For a time, it may seem as if the planet is writing carefully. The mud thickens. It is pressed into shale. It becomes part of a layer. But millions of years later, that layer may be lifted above sea level, exposed to rain and wind, cut by rivers, or ground down grain by grain until the record it held is scattered into new sediment somewhere else. The evidence was not false. It was not imaginary. It simply did not survive as a readable page. A mountain range may rise from rocks that once formed under the sea, but the same rise that reveals some layers can destroy others. Erosion can uncover a fossil bed and make discovery possible, while also removing nearby layers that might have explained the wider setting. The Earth gives and takes at the same time. It exposes one clue while erasing another. This is one reason the rocky record can feel so strange. It is both archive and active material. A library does not usually grind its own shelves into dust, fold its pages, bury its rooms, and melt its oldest volumes. Earth does. Its surface is shaped by weather, water, ice, gravity, heat, and movement from within. Its crust is not a fixed container. It is made of plates that shift slowly, opening ocean basins, closing them, lifting mountains, making volcanoes, and carrying some rocks into places where their original record cannot remain unchanged. This does not make geological history unknowable, but it does mean that the record has to be read as something damaged by the same forces that created it. The missing parts of Earth's story are not only in the spaces where no fossil appears, they are also in the spaces where the rock itself is gone, or where the layer exists but no longer speaks clearly. Sometimes the silence is not biological, it is geological. The page was not empty, the page was torn away. Erosion is one of the quietest editors of Earth's history. It does not need to arrive as a catastrophe. It can work as rain on a slope, wind across exposed ground, frost opening tiny cracks, waves cutting into a cliff, or a river carrying grains away one season at a time. Given enough time, erosion can remove not just a surface, but a long record of surfaces. A landscape that once received sediments may later become a landscape that loses them. A layer that once held traces of an ancient sea may be lifted into open air and slowly worn down until its shells, mud, minerals and small clues are no longer together in a readable order. This is why the Rocky Archive has a kind of silence that is different from the silence of missing fossils. In the fossil record, a body may fail to be preserved. In the rock record, an entire stretch of time may fail to remain. That missing stretch is not always visible as an empty hole. Sometimes it appears as a boundary, a contact between two rocks of very different ages, where time has passed but little or no sediment from that interval remains. Geologists call such breaks unconformities. The word sounds technical, but the idea is simple. The layers do not continue smoothly. Somewhere in that contact, time is missing from the local record. Sediment may have stopped accumulating there. Older rock may have been exposed and eroded. Later, new sediment may have covered the worn surface again, placing younger material directly on top of a much older story. To the eye, this can look like one layer resting on another, but to the history of Earth it can mean that millions of years, sometimes far more, are not recorded at that place. This belongs directly to the question of what is missing from Earth's story, because it shows that the planet's past is not missing only in invisible ways. Sometimes the absence is built into the rock itself. A surface can mark both preservation and loss at the same time. Below it, one story survived. Above it, another story began. Between them, there may have been rivers, soils, forests, shallow seas, deserts, weathering, life, death, and slow change that left little or nothing there for us to read. The famous idea of a great unconformity in some regions reminds us of this on a large scale, but the important lesson is not that every gap is a single mystery with one dramatic answer. The lesson is gentler and more difficult. Rock records are local, uneven, and interrupted. One place may be losing sediment while another is receiving it. One basin may preserve a careful sequence, while a nearby highland is being stripped away. A shoreline may move across land, leaving deposits in one age and eroding them in another. The same interval of time may be beautifully recorded in one region, faintly recorded in another, and absent somewhere else. So when scientists try to reconstruct Earth's past, they cannot treat one cliff, one canyon, or one quarry as the whole book. They compare many places. They date minerals. They follow layers across landscapes when possible. They look for volcanic ash beds, fossil assemblages, magnetic signals, chemical changes, and relationships between rocks. They ask not only what is present, but what kind of time may be absent. This is careful work, because a missing layer can be misunderstood if it is treated like a clean blank. A gap may represent erosion. It may represent a time when no sediment was being laid down. It may represent later deformation, faulting, or metamorphism. It may represent a surface that was exposed to weather for a long time before burial resumed. Each possibility changes the meaning of the silence. And still, even when the cause is understood, the lost details do not fully return. Knowing that a page was torn out does not restore every word on that page. It only tells us how to read the pages that remain. In this way, the rock record teaches the same humility as the fossil record, but on a larger and heavier scale. Stone seems permanent to human hands, yet stone too can be temporary in deep time. Mountains rise and are worn down, sea floors form and are consumed. Cliffs reveal layers while losing them. The earth is not only keeping a record beneath us, it is also revising, damaging, and recycling that record as part of its ordinary life. Even when rock is not completely removed, it can still lose part of its original voice. This is one of the harder things to feel at first, because stone seems so firm to us. We touch it and imagine permanence. We build with it, carve it, mark it, and trust it to last longer than flesh, wood, or memory. But in deep time, stone is not a final state. It can be buried beneath kilometers of sediment. It can be squeezed by pressure until its grains change shape. It can be heated by the slow warmth of the Earth's interior or by nearby molten rock. It can be fractured, folded, recrystallized, dissolved, replaced, or transformed into a new kind of rock whose minerals no longer preserve the old details clearly. This is where another part of Earth's missing story disappears in a quieter way. The page is not always torn out. Sometimes it is still there, but the writing has been blurred. A limestone that once formed in a shallow sea may later be changed into marble, beautiful to the eye but far less readable, as a record of the shells, mud, and water chemistry that made it. A shale that once held delicate traces of ancient life may be compressed, heated, and altered until its fine structures are faint or gone. A sandstone may be cemented, fractured, or cut by fluids that move through the rock long after it formed, leaving new minerals where older clues once were. None of this means the rock becomes useless. Metamorphic rocks, igneous rocks, and altered rocks can still tell powerful stories about pressure, temperature, tectonic movement, mountain building, and the deep processes of the planet. But they may no longer tell the same story they once held at the surface. They may remember the transformation more clearly than the earlier world that was transformed. This matters directly to the question of what is missing from Earth's story, because Earth does not only erase from the outside, it also changes its records from within. Plate tectonics slowly carries pieces of crust across the planet. Ocean floors are created at mid-ocean ridges and, in many places, eventually descend back into the Earth at subduction zones. Continental rocks may collide, buckle, and rise into mountain belts. Sediments that once settled gently in water may be caught in those collisions and pushed into heat and pressure, far beyond the conditions in which they formed. The original scene does not simply remain untouched, waiting for us. It is pulled into later chapters. It becomes part of new mountains, new minerals, new structures, new evidence of a different kind. So the missing past is not always a clean absence. Sometimes it is hidden inside a later presence. A mountain may contain rocks that began as seafloor mud. A polished marble wall may have begun as carbonate sediment under ancient water. A banded metamorphic stone may carry chemical hints of earlier conditions while losing the shapes that would have made those conditions easier to picture. In this way, the archive of Earth is not like a human archive at all. A human archive may decay if neglected, but it does not normally turn its letters into another alphabet. Earth does. It takes one kind of evidence and changes it into another. Scientists can still read parts of that new alphabet through minerals, textures, isotopes, structures, and relationships between rocks, but the reading becomes more difficult and more careful. They have to ask what the rock first was, what happened to it later, which signals are original, and which were added or changed by later heat, fluid, pressure, or deformation. This is why the rock record is both generous and unforgiving. It gives us mountain belts, crystals, ancient zircons, volcanic ash, seafloor fragments, folded strata, and traces of processes far older than human thought. But it also refuses to keep everything in the same form. It does not separate the story of life, climate, oceans, continents, and deep earth into tidy chapters. It lets them overlap, crush, burn, dissolve, and rewrite one another. By the end of this part of the journey, The missing chapters of Earth's story are no longer only about fossils that failed to form or layers that erosion carried away. They are also about evidence that survived physically, but changed so deeply that its first meaning became faint. The rock remains. The time remains in some form, but the earlier scene may no longer be recoverable in full. And that is perhaps one of the quietest losses of all. Not the disappearance of stone, but the survival of stone after its oldest memory has been altered. Long before any human eye looked across a coast or named a mountain, Earth had already worn many faces and lost them. The world we live on now can feel fixed because our lives are brief beside it. A shoreline may seem permanent if it stays in roughly the same place for a generation. A forest may feel ancient if its oldest trees were already there before our grandparents were born. A river valley may look as if it has always held the same shape, but deep time makes even the most solid landscape temporary. Seas move across continents and withdraw. Mountains rise from old ocean beds and then soften under rain, frost, and gravity. Deserts spread where water once moved. Swamps become coal. Coral reefs turn into limestone cliffs far from the sea. A place that is high and dry today may once have been a warm, shallow ocean. A place now covered by water may once have been open land, crossed by animals whose tracks were later drowned, buried, or erased. When we ask what is missing from Earth's story, we are not only asking about unknown creatures or broken layers of rock. We are also asking about lost worlds, entire arrangements of land, water, climate, plants, animals, and light that existed for long ages and then changed into something else. Some of these worlds left strong traces. Ancient marine sediments can tell us that seas once covered land. Coal beds can point toward old swampy forests. Glacial scratches on rock can show that ice once moved over a surface. Fossil reefs can mark the positions of vanished warm waters, but even these traces are not the lost world itself. They are the remaining outline after weather, burial, pressure, erosion, and later discovery have done their work. The full place is gone. The colour of the water, the daily pattern of clouds, the smell of wet plants, the ordinary sounds of insects, waves, wind, or animal movement are not preserved in the way a living observer would have known them. Science can recover many things carefully, but it cannot restore every hour of a vanished landscape. This is why the missing parts of Earth's story become more moving when we think of them as places rather than simply as facts. A shallow sea was not just a layer of limestone waiting to form. It was a habitat, with currents, mud, shells, reefs, predators, tiny drifting life, storms, quiet seasons, and chemical conditions changing slowly through time. A carboniferous swamp was not only future coal, it was a dense, wet environment of plants, decay, waterlogged soils, insects, amphibians, and slow accumulation. An ancient desert was not only sandstone, it was heat, wind, shifting dunes, dry basins, and rare traces of life passing through difficult ground. Each one was a real world while it existed, but the record that reaches us is compressed, partial, and often silent about the ordinary fullness of that world. Earth does not keep its old faces in a gallery. It wears one face, then another, and the earlier faces are folded into stone, washed into basins, lifted into cliffs, or reduced to chemical hints. To look at the present surface of the planet is therefore to see only the latest visible expression of something much older and more changeable. Beneath it, and sometimes within it, are traces of vanished oceans, buried forests, erased shores, drowned plains, and climates that would feel unfamiliar to us. The missing story is not somewhere separate from the Earth we know. It is inside the Earth we know, but thinned, altered, and scattered. The land around us is not only a place, it is also the remains of other places that no longer exist. To rebuild even a small part of a vanished world, scientists have to work from what the world left behind after it was no longer whole. A rock layer may show that water once covered a place, but the kind of water must be read carefully. Was it a quiet lake, a river channel, a tidal flat, a shallow sea, a deep basin, or a floodplain that dried and flooded again? The size of the grains can matter. Fine mud may suggest calmer water. Rounded sand can point toward movement. Cross-bedded sandstone may preserve the old motion of wind or current. Ancient soils can hint at exposure to air, roots, rainfall, drainage, and the slow chemical work of weather. Fossils can add another layer of meaning, but only when they are read with their surroundings. A shell in marine sediment says something different from a shell carried far from where it lived. A leaf found in fine lake mud may suggest nearby vegetation, but not every tree in the region. Pollen grains can travel by wind or water, so they may widen the picture while also complicating it. Chemical signals in rocks, shells, or minerals can suggest temperature, oxygen levels, salinity, volcanic influence, or changes in the carbon cycle, but those signals must be interpreted with caution, because later alteration can blur them. This is the patient work behind the question of what is missing from Earth's story. The lost world is not simply guessed. It is approached through many small surviving witnesses, each one telling a limited truth. A layer of coal may point toward a wet, plant-rich environment where organic matter accumulated faster than it fully decayed. But coal does not give back the exact afternoon light under those plants. It does not fully restore the insects moving through the damp air, the small animals hiding near roots, the rhythm of flooding and drying, or the countless days when nothing happened that would later become a clear mark. A fossil reef may show that warm, shallow water once supported a living community, but the reef as a place was more than its preserved skeletons. It had currents, shadows, colours, soft-bodied organisms, feeding patterns, competition, growth, damage, repair, and quiet intervals between storms. A desert sandstone may preserve the angle of ancient dunes, but not every wind that shaped them, not every track that crossed and vanished, not every rare rain that darkened the sand for a short time before the dry world returned. In this way, reconstruction is both powerful and limited. It can tell us that a place was once sea, swamp, forest, desert, ice margin, river plain, or volcanic land. It can sometimes show how that place changed. It can reveal broad climates, major shifts, and the presence of certain organisms. But the ordinary living thickness of the place is mostly gone. This is not a failure of care. It is the condition of deep time. The Earth gives us outlines, textures, fragments, signals, and patterns, but it rarely gives back the whole day-to-day world. The missing chapters are therefore not only about large mysteries, they're also about small lost details, the shade under vanished plants, the softness of mud before it hardened, the path of a river before it shifted, the soundless movement of animals whose bodies never fossilized, the shape of a coastline before waves and tectonics changed it. When we look at a reconstructed ancient landscape in a museum image or a scientific diagram, we are seeing an informed attempt to gather the surviving evidence into a scene. It may be honest, careful, and useful, but it is still a bridge built over absence. On one side is the evidence. On the other side is the vanished world. Between them is the missing space that no drawing, no model, and no sentence can fully close. The lost worlds of Earth are not truly gone in the simple way a dream is gone when morning comes. They are gone as living places, but parts of them remain folded into the present. A limestone ridge may be the compressed memory of an old sea. A seam of coal may be the darkened remains of ancient plant-rich wetlands. A dry cliff may carry the shape of ripples made by water that no longer touches that land. A mountain may contain rock that began as mud on a seafloor. A desert may hold sand grains that were once part of a much older mountain, worn down, moved, buried, and lifted again. The present surface of Earth is therefore not just the stage on which life now happens. It is also the latest cover laid over many earlier stages. When we walk across land, we are often walking over the altered remains of places that would have felt completely unfamiliar if we could have stood there in their own time. This is why the question of what is missing from Earth's story becomes more intimate than it first appears. The missing past is not only far away, not only locked in museums or buried in distant canyons, it is under roads, fields, forests, coastlines, cities, riverbeds, farms, and quiet hills. It is present as material, but absent as experience. The stone remains, but the sea is gone. The mineral remains, but the swamp is gone. The fossil remains, but the living movement is gone. The ancient soil may leave a faint horizon in rock, but the weather that formed it, the roots that entered it, the insects that moved through it, and the years that passed over it are mostly beyond recovery. This is the strange tenderness of deep time. Earth keeps traces, but not the whole life of the trace. It keeps evidence, but not the entire world that made the evidence meaningful. A cliff can tell us that sediment once settled there, layer after layer, but the cliff cannot give back every tide. A fossil shell can show that an animal once lived in water, but it cannot return the complete community around it. A volcanic ash bed can mark a moment of eruption, but it cannot restore every quiet year before and after that moment. The present is full of such remains, and yet each remain points towards something larger than itself. In that sense, every landscape is double. It is what it is now, and it is also what it has been made from. A valley is not only a valley, it may be the result of uplift, erosion, old rivers, changing climates, retreating ice, or softer rocks giving way faster than harder ones. A plain is not only flat ground. It may be a former seabed, a river deposit, a volcanic surface, or a place where older relief was worn down until the land grew gentle. A coast is not only a line between land and sea. It may be a temporary edge, moving across time as sea level, sediment, storms, and tectonics reshape it. Nothing in the visible world is as still as it appears. Avambasi, the missing chapters of Earth's story are hidden inside this movement. They are not always marked by dramatic signs. Often, they are present as quiet substitutions. Sea becoming stone, forest becoming coal, mud becoming shale, shell becoming limestone, mountain becoming sand, sand becoming sandstone, and sandstone becoming part of a future mountain. Each transformation keeps something and loses something. It keeps matter, it may keep structure, it may keep chemistry, but it loses the living arrangement, the passing weather, the exact relationships of organisms, the ordinary flow of time as it was felt by the world that existed then. This is why the lost worlds before human eyes can never be restored completely, even when the science is careful and strong. The aim is not to pretend that nothing is missing. The aim is to understand what remains without confusing it for everything that was. Earth's present face is beautiful, partly because it is layered with older faces, but those older faces come to us in fragments, hints, and altered forms. They ask to be read slowly. They ask us to notice that a stone is not just a stone, that a cliff is not just a wall, that a fossil is not just an object, and that the ground beneath us is not only beneath us. It is behind us, carrying pieces of vanished worlds forward, while leaving most of their living fullness in a silence we can approach, but never fully enter. The question of missing history becomes especially quiet when we approach the beginning of life. Here, the gaps are not only gaps between fossils, or gaps between layers, or gaps where old landscapes have been worn away. They reach into a time when the Earth itself was younger, hotter in many ways, still changing its surface, its oceans, its atmosphere, and its chemistry. To speak honestly about this part of the story, we have to move slowly. Science has found strong evidence that life is very ancient. There are very old rocks and chemical traces that suggest living processes were already present billions of years ago, and there are ancient microbial structures in some parts of the rock record that show life had become established far back in deep time. But knowing that life was present is not the same as knowing exactly how life began. The beginning itself remains one of the great unfinished passages in Earth's story. It is not unfinished because scientists have ignored it. It is unfinished because the earliest steps from chemistry to biology were small, fragile, and ancient beyond ordinary imagination. They may have happened in environments that were later destroyed, buried, altered, or recycled. They may have involved molecules that left no durable fossils. They may have occurred before there were bones, shells, forests, animals, or anything that could be preserved in the familiar way. If we ask what is missing from Earth's story, then the first life asks the question in its deepest form, How do you read a beginning when the earliest pages were written in materials that almost never last? A fossil shell can survive under the right conditions. A bone can mineralize. A footprint can harden in mud. But the first steps toward life would not have looked like those things. They would have involved chemistry, water, energy, minerals, simple organic molecules, membranes, replication, metabolism, or some early combination of processes that researchers still study and debate. Different scientific ideas explore different possible settings, such as shallow pools, mineral surfaces, hydrothermal environments, volcanic landscapes, or other places where energy and chemistry could interact. These ideas are not the same as final answers. They are careful attempts to understand what may have been possible on the early Earth. This distinction is important for honesty. A sleep story about Earth's past should not turn uncertainty into fantasy, and it should not pretend that a mystery has been solved just because a possible explanation sounds beautiful. The origin of life is not a blank space where anything can be inserted. It is a scientific question, surrounded by evidence, experiments, constraints, and limits. We know life existed very early compared with the age of the planet. We know life had to emerge from non-living chemistry somehow, because there was a time before biology and a time after biology. We know the early Earth provided water, minerals, energy sources, and chemical possibilities. But the exact pathway, the precise setting, and the sequence of steps remain uncertain. This is not a weakness in the story. It is the honest shape of the evidence. The early Earth did not preserve its most delicate transitions for us in a clear line. It did not leave a simple fossil of the first living thing with a label beneath it. It left scattered traces, altered rocks, chemical hints, and later life that had already passed far beyond its first beginnings. By the time life becomes visible enough for us to study with more confidence, it may already have had a long hidden history behind it. That hidden history is one of the missing chapters of Earth's story, and perhaps one of the hardest to imagine, because it is not only a missing creature or a missing landscape, it is the missing bridge between a planet with chemistry and a planet with life. When people hear that the origin of life is still uncertain, it can be tempting to treat that uncertainty as a doorway into anything, but that would misunderstand the nature of the question. Scientific uncertainty is not the same as emptiness. It is not a place where every idea has equal weight. It is a space bounded by evidence, chemistry, geology, experiments, and the limits of what the early Earth could have allowed. This matters deeply for the question of what is missing from Earth's story, because the missing beginning of life is one of the places where honesty is most important. We can say that life is ancient. We can say that early Earth had water, minerals, energy, and chemical environments that may have helped simple molecules become more organized. We can say that researchers study many possible pathways, from reactions on mineral surfaces to chemistry near hydrothermal systems, from wet and dry cycles in shallow settings to the formation of simple membranes and molecules capable of copying information. But we should not speak as if one complete pathway has already been proven, from the first non-living molecule to the first living cell. That line is still not fully drawn. The evidence does not allow that kind of certainty yet. And so, the most truthful way to stand before the origin of life is not to say nothing and not to invent too much, but to describe the narrow ground between what is known and what remains open. The early Earth was not an empty stage waiting for a miracle in the dramatic sense. It was a physical planet with oceans or bodies of water, active geology, volcanic activity, impacts especially early on, changing atmosphere, and many possible sources of energy. Chemistry could happen there. Molecules could form, break, concentrate, disperse, attach to minerals, react under heat, cool again, and enter cycles. In laboratories, scientists can test pieces of these possibilities. They can ask whether certain conditions help form organic molecules, whether simple membranes can assemble, whether chemical systems can become more complex, whether mineral surfaces can guide reactions, whether cycles of drying and wetting can concentrate ingredients that would otherwise remain too diluted. These experiments are valuable because they show what may be possible, but possibility is not the same as a recovered event. A laboratory can illuminate a pathway, It cannot simply replay the exact place and moment where life first crossed the threshold. That threshold itself may not have been a single sharp instant. It may have been a long, gradual transition, with many partial systems, many failures, many chemical arrangements that approached life without becoming ancestors of anything alive today. Most of those attempts, if they existed, would have left no direct trace. They would not have had shells. They would not have had bones. They may not even have had cells in the modern sense at first. They may have been fragile chemical systems in environments that later vanished. This is why the missing chapter of life's beginning is so different from a missing dinosaur skeleton or a lost coastline. It is not only that the evidence is rare, it is that the kind of thing we are looking for may have been almost impossible to preserve from the beginning. By the time life left clearer signs in rocks, it was already life. Something had already happened before the record became easier to read. The doorway had already been crossed, but the floor behind that doorway had mostly disappeared. To speak carefully about this is not to weaken the wonder of the story. It makes the wonder calmer and more real. The most important beginnings are not always the ones with the clearest monuments. Sometimes a planet changes forever, through steps so small, so chemical, so easily erased, that billions of years later the only honest thing we can say is that life began, but the full path by which it began remains one of Earth's deepest missing pages. The missing beginning of life does not make Earth's story empty. It makes it more delicate to tell. There is a difference between a story with no evidence and a story with evidence that cannot reach all the way back to the first moment. The origin of life belongs to the second kind. We are not standing before a blank wall. We are standing before a wall where some of the oldest markings are faint, altered, broken, or covered by later layers. We can see that life became part of Earth very early in the planet's long history. We can study ancient rocks, microbial traces, chemical signals, and the biology of living organisms that carry deep histories inside their cells. We can test possible steps in laboratories and compare them with what geology suggests about the young planet. But we cannot honestly point to one preserved object and say, here is the first life, here is the exact place, here is the complete sequence by which chemistry became biology. That kind of certainty is not available. And because it is not available, the honest story must remain open at its deepest root. This openness is not a failure. It is part of what the evidence teaches. The earliest life would have been simple compared with later plants and animals, but simple does not mean easy to recover. A microscopic cell is already a fragile thing. A pre-cellular chemical system would have been even harder to preserve. Molecules break down. Environments change. Rocks are buried, heated, altered, or destroyed. The early surface of Earth was active, and much of its oldest crust has been changed or recycled over time. The planet that could have recorded the first steps of life was also the planet most capable of damaging those records before any later mind could read them. So the missing chapter is not surprising when we think of the materials involved. It is surprising, perhaps, that anything from so early remains at all. This is why the story should be told with a kind of quiet gratitude for the traces that do survive, rather than with impatience toward the traces that do not. What is missing from Earth's story is not always missing because science has failed to ask the right question. Sometimes it is missing because the event itself left almost no durable language. The beginning of life may have been written in chemistry before it was written in fossils, in reactions before it was written in cells, in small changes before it was written in bodies large enough to leave marks. By the time the story becomes easier to see, life is already present, already adapting, already leaving signs that point backward toward a hidden passage. That hidden passage matters because everything that followed depended on it. Microbial worlds, oxygen-changing processes, complex cells, animals, forests, reefs, insects, dinosaurs, mammals, and eventually the minds asking these questions. Yet the passage itself remains partly beyond recovery. This is one of the deepest lessons of the unfinished Earth. The most important parts of a story are not always the best preserved. A beginning can shape everything after it, and still leave only a faint trail. To live with that truth is not to give up understanding. It is to understand more carefully. It is to let evidence speak as far as it can, and to stop before turning uncertainty into decoration. The first life reminds us that a missing chapter can be powerful without being filled by invention. It can hold our attention precisely because we know it was real in some form, because we know the world changed, and because we know the full path of that change has not survived in a way we can completely read. Earth's story did not begin with animals, or forests, or bones, or eyes looking back at the sky. It began somewhere deeper, quieter, and less preserved, in a transition that turned matter into something that could inherit, change, and continue. We can approach that transition with science, with experiments, with geology, with caution, and with wonder, but we cannot close it too neatly. The missing beginning of life remains a place where the story of Earth asks us not for certainty, but for humility. Some disappearances in Earth's story are large enough to leave a shadow we can still recognize. A boundary in the rocks changes. Certain fossils become rare, then vanish. Chemical signals shift. Layers of ash, shocked minerals, changes in carbon, or sudden differences in the kinds of life preserved can show that something major happened. These are the disappearances we can see more clearly, the great extinctions, the times when many branches of life were cut back, when oceans changed, climates shifted, volcanic activity altered the air and water, or an impact helped transform the surface conditions of the planet. We should speak about these events carefully, because even when an extinction is well supported by evidence, the details can be complex. It is rarely only one simple picture. Life disappears unevenly. Some groups suffer greatly while others survive. Some environments collapse quickly while others change more slowly. Some causes are strongly supported while other effects are still studied and debated. But even with that caution, the broad reality is clear. Earth has passed through times when much of life changed or ended, and the fossil record preserves enough of those changes for scientists to recognize them. Yet these visible disappearances are only part of the story. Around them, beneath them, and between them are countless smaller disappearances that may have left little or no clear mark at all. A local population could vanish from a valley when a river changed course. A species could disappear from an island when the climate shifted, without leaving a fossil that would ever be found. A soft-bodied lineage could fade away in an ancient sea and leave no bones, no shells, no hard pieces to mark its ending. A plant community could be replaced over thousands of years by another, while only scattered pollen or a thin change in sediment hints at what happened. In this way, extinction is not only a series of dramatic moments in deep time, it is also an ordinary process, happening quietly wherever environments change, competition shifts, habitats shrink, or chance presses against fragile life. This belongs directly to the question of what is missing from Earth's story, because the record of disappearance is even harder to preserve than the record of existence. To know that something lived, we need a trace. To know when it vanished, we need enough traces before and after its absence to recognize the pattern. But if a creature was rarely preserved while it lived, then its disappearance may be almost invisible. The rocks may not show a final scene, they may only stop speaking its name, and that silence can be difficult to interpret. Did the organism truly disappear then? Or has it simply not been found in younger rocks? Did it survive elsewhere? Did the right rocks fail to form? Were the fossils destroyed? Was the population small, local, soft-bodied, or living in an environment that rarely kept evidence? These questions make ancient extinction a careful subject, not a simple one. The end of a species is not always marked like the closing of a door. Sometimes it is more like a lamp going out in a distant room that no one was watching. By the time we notice the darkness, we may not know exactly when the light faded. This is why the disappearances we can see should make us think about the ones we cannot. The well-known extinction boundaries are important, but they are not the whole history of loss. Earth's story also contains invisible endings, branches of life that left no descendants we recognize, communities that changed without a clear boundary. organisms that vanished from places whose rocks were later erased, and worlds that ended too gradually or too quietly to leave a sharp line. The missing past is therefore filled not only with unknown beginnings, but with unknown endings. Life has not simply moved forward in a clean chain. It has spread, thinned, broken, recovered, and disappeared in ways that the archive can only partly hold. When we look at the life around us now, we are seeing the survivors of an immense filtering, not the full result of every path that was once possible. Behind every living branch are other branches that ended, and behind many of those endings there may be no clear fossil, no dramatic layer, no final trace, only the long silence of things that were real and then were gone. A species can disappear without leaving a final scene. This is difficult for the human mind, because we are used to endings that can be named. The last page, the last house on a road, the last voice in a room. But in deep time, many endings are not preserved as moments. They are stretched thin across geography, population, climate, chance, and the uneven survival of evidence. A creature may vanish from one region while still living somewhere else. It may become rare long before it becomes extinct. Its last living members may die in a place where no sediment buries them, where their bodies decay in open air, where acid soils dissolve their bones, where rivers scatter what remains, or where the rocks that might have held them are later destroyed. If that happens, the fossil record may not show the actual last individual, or even the actual last 1,000 years of the species. It may only show the last place where conditions happen to preserve it. This is why absence in the record must be handled carefully. When a fossil stops appearing above a certain layer, that can suggest disappearance, but it does not automatically prove the exact moment of extinction. It may mean the organism was gone. It may also mean it survived somewhere else, or that younger rocks from the right environment are missing, or that no one has yet found the evidence. This belongs directly to the question of what is missing from Earth's story, because endings are among the hardest parts of the story to capture. The beginning of a species can be blurred, and the ending can be blurred too. Between those blurred edges, the fossil record may give us a body, a shell, a tooth, a track, a pollen grain, or a trace of behavior, but rarely the full arc of life from first appearance to final disappearance. In many cases, what we call a last occurrence is really the youngest evidence found so far, not necessarily the true last breath of that form of life. Scientists understand this, and they treat it as part of the work. They compare many sites. They ask whether the rocks are continuous. They look at whether the same pattern appears in different regions. They consider how likely preservation was in each environment. They use dating methods, sedimentology, fossil assemblages, and sometimes chemical signals to narrow the question. But even careful work cannot always restore the final moment. The last members of a species may have lived quietly beyond the last preserved fossil, perhaps in small numbers, perhaps in a shrinking habitat, perhaps in a place the record did not keep. Their ending may have been biologically real, but geologically silent. This is a cold thought, but not a sensational one. It means that the history of disappearance is partly a history of uncertainty. A reef community may decline until only a few organisms remain, but the fossil record might preserve the reef when it was thriving, and then preserve a later environment after it was gone, leaving the fading itself unclear. A forest type may shift over centuries or millennia, but if the pollen record is incomplete or the sediments disturbed, the change may look sharper or more obscure than it really was. A small animal may disappear from the record simply because the few bones it left were never buried in the right place. A lineage may end without drama, not in fire or flood, but through fewer births, smaller ranges, changing food, shifting climate, or competition over long spans of time. The Earth may record the result without recording the process. And so, when we read ancient extinction, we are often reading shadows cast by events whose full shape is missing. Some shadows are strong, some are faint, some can be connected to major environmental changes. Others remain uncertain, not because they are mysterious in a cheap way, but because the evidence is thin. The important thing is to avoid turning every absence into a claim. A gap can suggest, it can warn, and it can invite more searching, but it cannot speak beyond what the rocks allow. This restraint is part of the honesty of the whole video. Earth's story includes many endings that no one saw, no one recorded, and perhaps no stone preserved completely. Somewhere, for countless forms of life, there was a final generation, a final nest, a final track, a final season, a final body returning to the ground. But the planet did not mark each one with a line. Most endings passed into the same quiet system that had always surrounded life. Decay, burial, erosion, movement, and time. What remains for us is not a clean list of final moments, but an uneven record of last traces, and around those traces, the deeper silence of lives that ended without becoming evidence. When we look at life today, it can be tempting to imagine a long, steady line leading toward the present, as if the living world were the expected result of a path that always knew where it was going. But Earth's story was never a single line. It was a branching, narrowing, breaking, renewing web of possibilities. Some branches spread widely for a time, and then ended. Some survived in small corners. Some changed into forms that would later become familiar. Others left no descendants we can recognize, and some may have left almost no fossils at all. The life around us is therefore not the full expression of everything that once tried to live. It is the surviving edge of an enormous history of loss. This matters deeply to the question of what is missing from Earth's story, because the missing parts are not only hidden beginnings or erased landscapes, they are also the lives that did not continue, the lineages that faded, the communities that collapsed, and the possible futures that ended before they could become part of the world we know. In the fossil record, some of these endings appear as clear changes. A group becomes less common, a set of fossils no longer appears above a certain layer, a once rich ecosystem is replaced by another. But many endings are softer than that. They may appear only as thinning, as absence, as a change in proportions, as a final scattered trace whose meaning becomes clear only when compared with other places, and many may never appear at all. This is why the history of life should not be told as if every missing branch were unimportant. A lineage can fail to survive and still matter to the world while it existed. It may have shaped food webs, disturbed sediment, spread seeds or spores, formed reefs, filtered water, competed with other organisms, sheltered smaller life, or altered the chemistry of its environment. Then, over time, it may have disappeared so completely that the later planet carried on without a clear memory of its role. The loss was real, but the record may be faint. That is one of the quietest truths in deep time. Reality and recoverability are not the same thing. Something can have happened fully and still be only partly knowable. A creature can have lived with all the fullness of being alive, and yet reach us only as a tooth, a shell, a trace, or nothing at all. A community can have changed the conditions around it for thousands or millions of years, and yet survive in the archive only as a shift in grain size, a chemical signal, a few pollen grains, or a gap that has to be interpreted with care. The disappearances we cannot see remind us that the present is not a complete museum of the past. It is a remainder. Every living species stands among many absences. Every ecosystem rests on a long history of replacements, extinctions, survivals, migrations, and recoveries. The green surface of the Earth today is not a simple victory over time. It is what remains after countless forms of life passed through conditions that selected some, removed others, preserved a few, and forgot many. To say this calmly is important. It is not meant to make the past feel hopeless or empty. It is meant to make it feel honest. Earth's story is not less beautiful because many branches ended. It is more humbling because it shows that life has always been vulnerable to place, climate, chemistry, accident, and time. The world did not move smoothly from simple to complex, from old to new, from failure to success. It moved unevenly, with expansions and collapses, long silences and sudden openings, survivors that seemed unlikely and dominant forms that eventually vanished. What we know from fossils gives us real structure. What we do not know leaves space around that structure. And in that space are the unseen endings, not dramatic scenes preserved for us, but quiet vanishings that shape the path of everything that came after. When we ask what is missing from Earth's story, we are also asking how many lives helped make the world and then disappeared from its memory. We are asking how many branches once held leaves in the sunlight of their own time, before time itself let them fall. To read what is missing, scientists first have to read what remains with unusual patience. They do not begin with the blank space and fill it with a convenient story. They begin with the surviving material, a layer of sandstone, a band of shale, a fossil shell, a chemical signal, a volcanic ash bed, a mineral grain, a change in pollen, a surface of ancient soil, a set of tracks crossing hardened mud. Each clue is small compared with the world it came from, but each clue has a position, a texture, a relationship to other clues. A fossil found alone can be interesting, but a fossil found inside a certain rock, above one layer and below another, near certain minerals, beside certain traces of water or land, becomes part of a wider pattern. This is how the missing parts of Earth's story are approached honestly, not by pretending the gap is gone, but by surrounding it with evidence until its shape becomes clearer. If a layer is absent in one place, scientists may look for the same interval somewhere else. If a fossil group disappears in one region, they may ask whether it appears in another. If a rock was eroded, they may look for the sediment that erosion carried away. If an ancient environment left only chemical hints, they may compare those hints with sediments, fossils, and modern processes that are understood more clearly. This work is slow because Earth's archive is not arranged for human convenience. Its pages are scattered across continents. Some are tilted into mountains. Some are buried under younger rock. Some lie beneath oceans. Some have been altered. Some are exposed only because erosion has cut through them. A single canyon, cliff, quarry, or outcrop may give a powerful view, but it is never the whole story by itself. The question is always larger. How does this piece connect to other pieces? How old is it? What formed it? What changed it later? Was this place receiving sediment, losing sediment, drying, flooding, sinking, rising, heating, cooling, or being cut by rivers? The missing chapters of Earth's story begin to take shape through these comparisons, but they do not become complete in a simple way. They become better constrained. That word matters. To constrain a question is not the same as solving it completely. It means narrowing what is possible, ruling out weaker ideas, and holding the remaining possibilities close to the evidence. If a rock contains marine fossils, it may suggest that sea covered that place, but the depth, temperature, chemistry, and exact living community require more evidence. If a layer of ash can be dated, it can give an age to nearby rocks, but it does not automatically explain every change around it. If a chemical signal shifts, it may point toward a change in climate, ocean chemistry, volcanic activity, burial, or life processes, but the signal must be tested against other records. This is why science often sounds careful when it speaks well. It uses words like suggests, indicates, is consistent with, may reflect, and is supported by, not because it is weak, but because the Earth rarely gives one clue that explains everything. The missing story must be approached through many clues, agreeing, disagreeing, correcting, and limiting one another. In that sense, scientists do not read absence as silence alone. They read the edges of silence. They ask what the rocks before and after a gap can say, what similar rocks elsewhere can say, what the chemistry can say, what the fossils can say, and what the damage itself can say. The blank space is not filled recklessly. It is outlined carefully, like the shape of a lost object remembered by the dust around it. One of the quiet strengths of geology is that it gives scientists more than one way to ask the same question. If one kind of evidence is broken, another may still speak. If fossils are rare, minerals may help. If a layer is missing in one place, the same time interval may be preserved somewhere else. If a landscape has been erased, grains carried from it may survive in a basin far away. This is how the missing parts of Earth's story become partly readable. Scientists do not depend on a single clue standing alone. They build a web of clues, and the web becomes stronger when different kinds of evidence point in the same direction. Dating methods are part of this work. Some rocks and minerals contain elements that change into other elements at known rates over very long times, allowing scientists to estimate when a mineral formed or when a volcanic ash layer was deposited. These dates can help place nearby fossils and sediments into a larger timeline, but even a date is not a whole story. It tells us when something formed, cooled, crystallized, or was deposited, depending on the method and material, and that meaning has to be understood carefully. A volcanic ash bed between two sedimentary layers can be extremely useful because it may give an age marker, but the mud above and below still has to be read for environment, water, climate, and life. Layer comparison is another tool. When similar rock sequences appear in different places, scientists ask whether they belong to the same interval, the same ancient basin, the same shifting sea, or the same broad environmental change. Fossils can help correlate layers. So can ash beds, magnetic patterns, chemical signals, and the order of sediments. This matters for the question of what is missing from Earth's story, because a gap in one cliff may not be a gap everywhere. One place may have been eroding while another place was quietly collecting mud. One landscape may have lost its record while a distant basin kept part of it. By comparing many locations, scientists can sometimes see around a missing page, even if they cannot restore the page itself. Chemical traces also help, especially when bodies and landscapes are poorly preserved. The ratios of certain isotopes, the presence of particular minerals, changes in carbon, oxygen, sulfur, iron, or other signals can suggest shifts in climate, ocean chemistry, oxygen levels, volcanic activity, weathering, or biological processes. But chemical evidence must be handled with care because rocks can be altered after they form. Fluids can pass through them. Heat can change them. Pressure can reorganize minerals. Later events can overprint earlier signals. So scientists ask whether a chemical pattern is original, whether it appears in many places, whether it matches the sediments and fossils around it, and whether another explanation is possible. The same caution applies to ancient environments. A sandstone does not simply mean desert. It may have formed in a river, a beach, a dune field, a delta, or another setting depending on grain size, sorting, structures, fossils, and surrounding layers. Mudstone does not simply mean deep water. Limestone does not always mean the same kind of sea. Each rock is read through its details and its context. This is why science can distinguish, at least sometimes, between nothing happening and no evidence remaining. If a surface shows signs of long exposure, weathering, soil formation, or erosion, then the absence of new sediment may itself tell a story. If rocks above and below a boundary are very different in age, the contact may mark missing time. If an environment was dry, exposed, acidic, steep, or heavily eroded, then poor preservation may be expected. If, on the other hand, rocks from the right environment exist and have been well studied, a true biological absence may become more likely. The difference is subtle, but it is essential. Earth's missing story cannot be read by absence alone. It has to be read by asking what kind of absence it is. Is it a missing layer, a missing fossil, a damaged signal, a local gap, a global pattern, an undiscovered record, or a record that never had good conditions to form? The more carefully these questions are asked, the more honest the story becomes. Science does not make the missing past complete. It gives the missing past edges, dates, causes, limits, and degrees of confidence. It teaches us to say, this much is supported, this much is possible, this much remains uncertain, and this part may be gone beyond recovery. The value of science is not only that it discovers things, it is also that it learns how to stop before it says too much. This may sound like a small virtue, But when we are dealing with the missing parts of Earth's story, it becomes one of the most important virtues of all. A beautiful idea is not enough. A dramatic explanation is not enough. A smooth story that fills every blank space is not enough. The past has to be approached through what can be tested, compared, dated, measured, and checked against other evidence. This is why careful science often sounds less certain than a myth, less complete than a legend, and less emotionally satisfying than a story with every question answered. But that restraint is not weakness. It is the reason the story can be trusted. When scientists say that a rock layer suggests an ancient sea, they are not simply being timid. They are leaving room for the details that may still be uncertain. Whether the water was shallow or deep, warm or cool, open or restricted, quiet or disturbed, rich in oxygen or poor in it. When they say that a chemical signal is consistent with a changing climate or ocean chemistry, they are not refusing to explain. They are acknowledging that one signal must be tested against many others before it can carry too much weight. When they say that a fossil may represent a transitional form, or that a disappearance may reflect extinction, poor preservation, or undiscovered rocks, they are not weakening the past. They are protecting it from being made simpler than it was. This matters directly to the question of what is missing from Earth's story, because missing evidence can be very easy to misuse. A gap can be made to look like a secret. A silence can be turned into a claim. An uncertainty can be dressed up as proof for almost anything if the listener is not careful. But the more honest path is slower. It asks, what do we actually have? Where was it found? How old is it? What process could have made it? What later process could have changed it? Does the same pattern appear elsewhere? Are there other explanations? How strong is the evidence? What remains unknown? These questions do not make the story colder. They make it cleaner. They allow wonder without pretending. They allow mystery without confusion. They allow us to feel the depth of the unknown, while still respecting the boundary between evidence and imagination. This is perhaps the most useful lesson in reading Deep Time. The missing parts of Earth's story are not an excuse to believe less carefully. They are a reason to look more carefully. A blank space in the record can teach us about erosion, non-deposition, poor preservation, tectonic recycling, chemical alteration, limited exposure, or the simple fact that not all rocks have been found and studied. It can also teach us that some things may never be recovered, but each of those possibilities has to be earned by evidence. The silence itself must be interpreted with discipline. In this way, science does not only collect facts about the planet, it teaches a way of thinking. It teaches us to separate what is known from what is inferred, what is likely from what is possible from what is merely imagined. It teaches us that an honest answer may include uncertainty without collapsing into confusion. And for a story as old and damaged as Earth's, that may be the only truthful way to speak. We are not trying to force the planet into a perfect narrative. We are trying to listen to what remains, notice what is missing, and avoid making the missing parts say more than they can. By the end of this part of the journey, the unfinished nature of Earth's record no longer feels like an obstacle to knowledge. It becomes part of knowledge itself. The gaps, the breaks, the altered rocks, the absent fossils, the uncertain beginnings and endings all remind us that understanding is not the same as possession. We do not own the past by explaining it. We meet it through traces, and we learn to be careful in their presence. The most trustworthy story of Earth is not the one that answers every question too quickly. It is the one that can say, with calm honesty, here is what the evidence shows, here is what it may suggest, and here is where the silence still remains. When we turn from the rocks back toward ourselves, the missing parts of Earth's story begin to feel different. At first, they may seem like a scientific problem, something belonging to fossils, minerals, ancient seas, and vanished landscapes. But slowly, they become a lesson in scale. We live inside a very small opening of time. Our bodies last for decades. Our buildings may last for centuries if they are cared for. Our oldest stories reach back only a tiny distance compared with the age of the planet. Even human civilization, with all its memory, writing, cities, maps, measurements, and archives, is extremely recent beside the long history written and erased in stone. The Earth was changing for billions of years before anyone stood under the sky and wondered what had come before. Seas advanced and withdrew. Mountains rose and wore down. Life began, changed, spread, suffered, vanished, and returned in new forms. Whole worlds opened and closed without witness. By the time human beings became able to ask questions, most of the story was already gone, altered, or hidden in fragments. This is why the question of what is missing from Earth's story is also a question about humility. It reminds us that our knowledge, even when careful and powerful, arrives late. We are not reading a record made for us. We are trying to understand a planet that had no reason to preserve itself in a way human minds would find complete. This does not make us insignificant in a hopeless sense. It makes us temporary readers of something much older than ourselves. There is a quiet dignity in that position. We can look at a fossil shell and understand that a sea once moved where there may now be dry land. We can look at a band of coal and recognize the remains of ancient plant-rich wetlands. We can look at a gap between rocks and understand that time passed there, even if the local record no longer holds it. These acts of understanding are small compared with the whole past, but they are not meaningless. They show that a brief life can still notice deep time. A mind that exists for only a moment in geological history can still learn to read a trace that survived for millions of years. Yet the same act of reading should also soften our certainty. The missing story teaches us not to mistake our maps for the whole Earth, our diagrams for the whole past, or our reconstructions for the complete worlds they represent. It teaches us that every explanation should carry the weight of what it does not know. This is especially important in an age when information can sound complete, even when it is not. A simple image, a short sentence, a dramatic claim can make the past appear finished, as if every mystery has a clean answer or every gap hides a secret. But Earth's real history is more patient than that. It does not reward speed. It asks for comparison, restraint, context, and time. The missing chapters remind us that not knowing everything is not the same as knowing nothing. Between ignorance and certainty, there is a wide, honest space where careful learning takes place. That space is where much of science lives. It is also where a calmer kind of wonder can live. We do not need to exaggerate the unknown to feel its depth. We do not need to pretend that every gap is strange in order to feel how vast the past is. The ordinary truth is already large enough. The planet beneath us has kept a full part of what happened, and still that partial record is rich enough to change how we see ourselves. We become less like owners of the Earth story and more like late visitors in an old archive, holding a few surviving pages gently, aware that many more were lost before we arrived. Understanding that Earth's story is incomplete can change the way we look at the present. It can make an ordinary stone feel less ordinary, not because we imagine more than it can tell us, but because we understand how rare it is for anything to tell us anything at all. A rock on a hillside may have passed through water, pressure, burial, uplift, fracture, and weather before it reached the surface where a human hand could touch it. A shell in limestone may have crossed an almost impossible distance of time before becoming visible. A fossil leaf may represent not only a plant, but the unusual moment when mud, water, chemistry, and later survival allowed one fragile shape to remain. When we realize this, the present world becomes quieter and deeper. It is no longer only a surface filled with familiar things. It is a surface resting on vanished seas, buried soils, former climates, old rivers, altered mountains, lost habitats, and living worlds that no longer have voices of their own. This directly answers the question of what is missing from Earth's story, because the missing parts do not only make the past less complete, they make the surviving parts more valuable. Every trace has become a kind of exception. Most bodies vanished, most tracks were erased, most soft tissues decayed, most landscapes changed beyond recognition, most days left no record. So when a trace remains, It deserves careful attention. It should not be rushed into a dramatic claim, and it should not be treated as decoration. It is a survivor. 1. The same understanding can also protect us from easy certainty. If the archive is incomplete, then a fast answer can be dangerous. A simple claim may sound satisfying, but it may ignore erosion, poor preservation, missing rocks, altered chemistry, local conditions, or the difference between absence and true non-existence. A clean story may be easier to remember, but Earth did not become easy for our convenience. Its past is layered, broken, and uneven. To respect that past, we need patience with uncertainty. We need to ask what the evidence actually shows, what it only suggests, and what it cannot yet answer. This habit is useful beyond geology. It teaches a way of thinking that is slower and less hungry for immediate closure. In daily life, people often want every silence to mean something clear, every gap to hide a secret, every fragment to complete a story. But the Earth teaches a different lesson. A gap may be meaningful, but it may not have a simple meaning. A missing piece may change the picture, but it does not give permission to invent the picture. A trace may be true, but it may be only one surviving edge of something larger. This is why the missing history of Earth can make the present feel more honest. It reminds us that knowledge is strongest when it knows its own limits. It reminds us that careful uncertainty is not emptiness. It is a form of respect. When scientists reconstruct an ancient coastline, a vanished forest, or the disappearance of a species, they are not only collecting facts, they are practicing restraint in the presence of time. They are saying, this much remained, this much can be compared, this much can be tested, and beyond this line the story must stay open. There is a quiet beauty in that. It allows wonder to remain without turning wonder into false certainty. It allows mystery to remain without making mystery cheap. And it allows the listener to feel the size of Earth's past without being frightened by it. We live on the newest visible layer of a very old planet. Beneath our feet are many earlier worlds, most of them incomplete, many of them altered, some of them nearly lost. The present becomes more precious when we understand that it too is temporary. The shores we know, the forests we walk through, the rivers we name, the cities we build, and even the records we keep are not outside time. They are part of the same moving Earth that preserves some things and erases others. One day, much of our own world may also become fragment, trace, chemistry, sediment, or silence. To understand the missing chapters of Earth's past is therefore to look at the present more gently, knowing that what remains is always rare, and what disappears is never proof that it did not matter. The more we think about the missing parts of Earth's story, the more they begin to resemble a lesson in memory. Not human memory, with its images, names, voices, and emotions, but planetary memory which works through matter. Earth remembers in layers, minerals, fossils, scars, grains, chemistry, shapes, and absences. It remembers slowly, and it forgets slowly too. It does not forget, because it is careless. It forgets because forgetting is built into the same processes that make the planet alive as a geological system. Water moves, rock breaks, sediment travels, heat alters, pressure transforms, plates shift, surfaces rise and fall, living things decay and return their materials to other forms. The planet's memory is therefore not separate from the planet's change. It is made by change, and it is damaged by change. This is why the question of what is missing from Earth's story reaches beyond science into the way we understand time itself. We often want the past to remain available, especially when the past feels important. We want beginnings to be clear, endings to be marked, causes to be complete, and evidence to wait patiently until we are ready to ask. But deep time does not obey that desire. It gives us real knowledge, but not total knowledge. It gives us enough to learn, but not enough to possess the whole. It gives us fossils that survived while countless bodies disappeared, rocks that remained while other layers were carried away, chemical traces that endured while whole environments lost their living texture. And so, the missing chapters of Earth's story teach a kind of humility that is not simply intellectual, it is emotional as well. They ask us to accept that something can be real and still unrecoverable. Something can matter and still leave no durable sign. A vanished coastline was real, even if its shape cannot be fully drawn. A lost species was real, even if its final generation left no fossil. A forest that rotted back into soil was real, even if no trunk became stone. A day in the deep past was real, even if nothing from that day entered the archive. This is a hard truth, but it is also a gentle one, because it frees us from thinking that only what is preserved was meaningful. Earth's record is not a measure of worth. It is a record of survival under conditions. What remains is valuable, but what disappeared was not therefore empty. This matters for us because human beings also live inside time, and we also depend on fragile forms of memory. We write, build, photograph, measure, archive, and name things because we know how easily they can vanish. Yet even our records are temporary beside geological time. Paper decays, digital storage fails, buildings collapse, cities are buried, rebuilt, flooded, or abandoned. Languages change, names are forgotten. One day, much of what feels permanent to us may be reduced to scattered materials, altered chemistry, or no clear trace at all. This thought should not make the present feel meaningless. It can make it feel more tender. We are part of the same earth that preserves selectively and erases silently. Our lives are brief, but they are not outside the story. They belong to its newest layer. The lesson is not that everything disappears, so nothing matters. The lesson is that disappearance does not cancel meaning. A trace is rare, and a living moment is rare too. When we understand this, the missing history of Earth becomes less like a failure and more like a quiet teacher. It teaches us to hold evidence carefully, to speak honestly about uncertainty, to avoid filling silence with easy invention, and to respect the immense amount of life and change that no archive could ever fully keep. By the end of this human turn toward the planet's past, we are not closer to owning the whole story. We are closer to knowing how to stand before it, with curiosity, with caution, with gratitude for what remains, and with respect for what time has taken beyond our reach. To live with Earth's unfinished story is to let go of the need for every question to close. This does not mean giving up the search. It means changing the spirit of the search. For much of this journey, we have looked at what is missing. Bodies that never fossilized, landscapes that were erased, rocks that were altered, beginnings too fragile to preserve, endings that left no final scene, and silences that can only be understood by reading the edges around them. It would be easy to treat all of this as a loss only, as if the incompleteness of Earth's record were a weakness in the story. But perhaps the deeper lesson is different. The missing parts do not make the story less true. They make truth more careful. They remind us that knowledge is not the same as possession, and that understanding a thing does not require owning every moment of it. The Earth has never offered itself as a complete explanation. It offers fragments, patterns, relationships, traces, and limits. It gives enough for patient minds to learn, but not enough for careless certainty. That is why the question of what is missing from Earth's story has to end not with frustration, but with a quieter form of respect. A broken archive is still an archive. A damaged record can still teach. A fossil does not need to restore an entire vanished world in order to matter. A layer of stone does not need to preserve every year in order to speak of ancient water, old climates, buried surfaces, or the passing of time. A chemical trace does not need to answer every question in order to point toward a change that once moved through oceans, air, life, or rock. The value of evidence is not that it gives us everything. Its value is that it gives us something real. And when something real survives from deep time, it deserves to be treated with more care, not less. This is the educational center of the whole story. Missing evidence should not push us toward fantasy, and uncertainty should not push us toward pretending. There is a middle path, and it is slower. It asks us to say what we know, to say how we know it, to say what is only suggested, and to say what still remains beyond reach. This way of thinking is useful far beyond geology. It teaches us how to live with incomplete information without becoming careless. It teaches us that a blank space is not automatically a secret, that a silence is not automatically proof, and that a beautiful explanation must still answer to evidence. Earth's history gives this lesson on a scale larger than human life. It shows that reality can be vast, meaningful, and partly unrecoverable at the same time. There were oceans no eye saw, forests no voice named, species no mind remembered, and days that passed through the planet without leaving a mark. Yet those days still belong to the story. Their disappearance does not make them unreal. It only means the record could not carry them forward. So the unfinished Earth asks something gentle but difficult from us. It asks us to wonder without exaggerating, to question without rushing, to learn without needing every gap to close. It asks us to see the difference between mystery and confusion, between evidence and invention, between humility and emptiness. We do not honor the missing chapters by filling them too quickly. We honor them by listening closely to the chapters that remain and by allowing the silence around them to stay honest. The most useful gift this unfinished story can give us is a clearer way to think. Whenever we meet a gap in Earth's history, we can ask a few quiet questions before we reach for an answer. What evidence is actually present? Is it a fossil, a rock layer, a chemical signal, a mineral date, a trace of an old environment, or only an absence where we expected something to be? Where was it found, and what kind of place was that when the evidence formed? Did the material have a good chance of being preserved, or was it born in conditions where almost everything would normally disappear? Has the rock been altered by heat, pressure, fluids, erosion, or tectonic movement? Does the same pattern appear in other places, or only in one exposed wall, one quarry, one basin, one fragile record? These questions may sound slow, but that slowness is exactly what protects the story from becoming false. A gap is powerful because it invites attention, but it is also dangerous because it invites invention. The mind wants completion. It wants a missing layer to have one clear cause, a missing fossil to mean one clean disappearance, an unknown beginning to become one beautiful scene. But Earth does not become more truthful when we make it simpler than it was. The honest path is to keep different levels of knowledge separate. There is what the evidence shows directly. There is what the evidence strongly suggests. There is what remains possible but unproven, and there is what may be imagined but cannot yet be supported. These are not small differences. They are the difference between education and decoration. If a fossil is found in a certain layer, that fossil is evidence of presence there. If similar fossils appear across many layers and regions, they can help reveal patterns of distribution, change, and time. If a group stops appearing, that may suggest disappearance, but the strength of that suggestion depends on how complete the rocks are, how likely preservation was, and whether other regions have been checked. If ancient chemistry shifts, it may point toward a change in oceans, air, climate, volcanism, weathering, or life. But one signal alone must be compared with others before we lean too heavily on it. This way of thinking is not cold. It is respectful. It refuses to force the planet's silence into words it did not say. It allows us to feel wonder while still asking for support. It lets a mystery remain a mystery without turning it into a claim. And for a listener, this may be the most practical lesson hidden inside deep time. Not every blank space must be feared, filled, or explained at once. Some blank spaces ask us to wait. Some ask us to search more carefully. Some ask us to admit that the evidence has limits. Some ask us to accept that the past was real, even where it has become unrecoverable. This is especially important in a world where stories can spread faster than careful understanding. A dramatic title can make a gap sound like proof of something extraordinary. A striking image can make an uncertain reconstruction feel like a photograph. A confident voice can make a weak idea sound settled. But the Earth's own record teaches a different rhythm. It teaches us to pause between the trace and the conclusion. It teaches us to ask what kind of confidence a claim deserves. It teaches us that a truthful sentence may be quieter than a sensational one, but it lasts longer. The missing chapters of Earth's story are not there for us to exploit. They are there, in a sense, to discipline our curiosity. They remind us that curiosity becomes wiser when it accepts boundaries. We can look into the gaps with open eyes, but we do not have to pretend that every shadow contains a finished answer. Sometimes the most honest thing we can say is simple. This part is known, this part is suggested, this part is still being studied, and this part may remain beyond us. In the end, Earth does not need to become a complete story in order to teach us. It may never give back every beginning, every lost species, every vanished coast, every first step from chemistry into life, every last breath of a lineage, every ordinary day that passed before there were eyes to witness it. Much of that is gone, not because it was meaningless, and not because it was waiting behind some hidden door, but because time on a planet like this does not keep everything. It buries and exposes. It preserves and destroys. It lifts old seafloors into mountains and wears mountains into sand. It turns bodies into minerals, forests into dark seams, mud into shale, shells into limestone, and entire worlds into traces so thin that only careful attention can hear them. What remains is enough to humble us and enough to guide us, but never enough to let us pretend that we have held the whole past in our hands. This is the final shape of the question. What is missing from Earth's story? The answer is not one lost chapter, one vanished world, one broken layer, or one unsolved beginning. The missing part is woven through the entire record. It is in the lives that never fossilized, the rocks that were never formed, the layers that were formed and later erased, the signals changed by heat and pressure, the landscapes that survive only as hints, the extinctions that left no final scene, and the origins that became hidden before the story grew clear enough to read. But the purpose of seeing this is not to make the past feel unreachable. It is to make our relationship with the past more honest. We can still learn. We can still reconstruct. We can still follow sediment across a basin, compare fossils across continents, measure minerals, read chemical changes, and watch old environments rise faintly from the evidence. We can still say that seas once covered land, that life is ancient, that species have come and gone, that climates have shifted, that the planet has changed its face many times. These truths matter. They are not weakened by the silence around them. They are strengthened when we admit where their edges are. A careful truth, with clear limits, is more valuable than a dramatic answer that reaches beyond the evidence. And perhaps that is the quiet educational message this journey leaves behind. In a world full of quick certainty, the Earth teaches a slower kind of intelligence. It teaches us to notice what is present, to ask what is absent, to separate evidence from wishful completion, and to let unanswered questions remain unanswered until the record gives us more. It teaches us that not every silence is a secret, not every gap is proof, and not every mystery needs to be made louder to be meaningful. The oldest stories are often the most incomplete, and still, they can change the way we live in the present. They can make us gentler with what survives. They can make us more careful with what we claim. They can remind us that our own moment too is temporary, resting on a planet that will continue to change long after our names, our maps, and our familiar coastlines have faded. We are not outside the unfinished story. We are one of its recent pages, written lightly, briefly, on the surface of a world that has already forgotten more than we will ever know. And as we close our eyes before that immense, damaged, beautiful archive, the final question does not need to be answered. It only needs to remain open in the dark. If Earth has kept only fragments of what happened, how much of its deepest story will always stay beyond the reach of memory?